My name is S.A.ENGG.COLLEGE Shiny. I am working as an assistant professor in CSE department, S.A.ENGG.COLLEGE. In today's GATE coaching class, we are going to see about CPU scheduling. So before learning about CPU scheduling, you have to know about operating system. I hope you all know about operating system. So now we can start with process. So what is a process? A process is an instance of computer program. It is also called as thread. It can be a single thread or it can be a multiple thread. If there are more number of threads, then we can say it as a multiple threads, and the process can also be executed concurrently. So this is the definition for process. So next you have to know about process scheduling. So whenever you are having more number of process in your CPU, it has to be scheduled. So that is done by process manager. He is the responsible for allocating the CPU for each and every process. So here there are three types of process schedulers. One is long-term scheduler, one is short-term scheduler, another one is medium-term scheduler. So long-term scheduler is also called job scheduler, short-term scheduler is also called CPU scheduler, and medium-term scheduler, there is no other name for this, you can represent it as a medium-term scheduler itself. So these are the various type of process scheduling. So why there is a need for CPU scheduling algorithm? So it is the process of deciding which program can hold the CPU. So for that we should have some mechanism for scheduling the program to our CPU. So for this only we are studying about various CPU scheduling algorithms. This CPU scheduling algorithms will help the program to be assigned to the CPU. So the main motive of our CPU scheduling is the CPU should not be idle. All the process must be allotted to the CPU. So that's why we are studying about CPU scheduling algorithms. So what are the main objectives of CPU scheduling algorithm? So whenever you are going to learn about a new topic, you should know what are the objectives of a scheduling algorithm. So that's why we are going to see about what are the objectives of process scheduling. So first one, we always make sure that CPU is busy. The CPU should not be idle. It must be allocated with each process. And then an allocation of CPU should be fair. It means that each and every process that enters the CPU must be allotted with the CPU in some form of fashion. So there should not be any uneven in allocating the resources. So we have to make sure that CPU is allotted evenly. And the third one is throughput should be maximum. So what is throughput? The number of processes that complete their execution per time unit should be maximum. So in unit time, the more number of processes must be completed. So that is the definition of throughput. And then minimum turnaround time. So turnaround time is nothing but execution time. So how long the process is going to use the CPU. So that is called turnaround time. Always the turnaround time must be minimum. So always you have to keep this in mind. So while doing your problems, this turnaround time, waiting time, response time, all these terms you should have clear idea. Then only you can solve the problems easily. And then minimum waiting time. So what is waiting time? So whenever a process is entering the ready queue, the process has to be allotted with the CPU. So always the waiting time must be minimum. And finally minimum response time. So whenever the process is responding, the first response must be happen as soon as possible. So always the response time must be minimum. So these are the objectives of process scheduling algorithms. So these are the terminologies you have to know before solving your problem. So first one is arrival time. So arrival time is the time whenever a process is entering the ready queue. That is arrival time. And completion time, whenever a process is completing its job, that time is called completion time. And burst time, the other name for burst time is execution time. How long a process is executing or using the CPU, that is called burst time. And turnaround time, that is the difference between the completion time and arrival time. So completion time in the sense how far a process is using the CPU and the process is completing its job, that is called completion time. And arrival time is whenever a process is entering the queue, that is the arrival time. So the difference between the completion time and arrival time is called the turnaround And the last time is waiting time. So waiting time is the difference between the turnaround time and burst time. What is the other name for burst time? It is the execution time. So the difference between the turnaround time and the burst time is called the waiting time. So all these terms you should have clear idea before solving your problem. You should know what is arrival time, what is completion time, what is burst time, what is turnaround time, and what is waiting time. So hope you all have clear understanding about this. So there are two types of algorithms. Mainly our CPU scheduling algorithms will be of these two types. One is preemptive scheduling and another one is non-preemptive scheduling. So let's see the definition of preemptive scheduling. So preemptive scheduling is used whenever a process switches from the running state to the ready state or from the waiting state to the ready state. So whenever a process is switching to the ready state, that is called preemptive scheduling. And non-preemptive scheduling, when a process terminates, whenever a process is allocated with the CPU, the process will be completing the task, then only the CPU can be allotted to the next process. That is non-preemptive scheduling. So these are the main types of CPU scheduling algorithm. One is preemptive and another one is non-preemptive scheduling algorithm. So next we can see the overall classification of CPU scheduling algorithm. So basically, as I told before, there are two CPU scheduling algorithms. One is preemptive and another one is non-preemptive. In preemptive is again classified into next four. One is priority scheduling, another one is longest remaining job first, and another is shortest remaining job first, and round robin. So all this comes under preemptive scheduling. And next one is non-preemptive scheduling. In this you will have FCFS, that is first come first serve scheduling, SJF, that is shortest job first scheduling, and longest job first scheduling, and highest response ratio text. So these are the various CPU scheduling algorithms. So in today's class we are going to see about SJF and round robin. So what is SJF? Shortest job first scheduling. And what is round robin algorithm? Or algorithm. It can be or algorithm or round robin algorithm. So in today's class we are going to solve problems on SJF algorithm and round robin algorithm. SJF algorithm, that is shortest job first scheduling algorithm. So now we are going to see about this SJF. So as the name indicates, which process is having shortest execution time, that process will be allotted with the CPU. So that is SJF algorithm. So it can be preemptive scheduling algorithm or can be non-preemptive scheduling algorithm. It reduces the waiting time. So whenever a process is entering with execution time, which process is having least execution time, that will be allotted with the CPU. So that is the advantage of using shortest job first algorithm. So comparing to all other algorithm, the waiting time will be very less in the shortest job first algorithm. So as I said before, compared to all operating system scheduling algorithm, so SJF have the advantage of having minimum waiting time. So next algorithm, what we are going to see is RR algorithm, or it is called round robin algorithm. So it is a CPU scheduling algorithm where each and every process is given a fixed time slot. Within that time slot only that process will be allotted with the CPU. Once that time is expired, automatically the process will be sent out from the CPU. So this is about round robin algorithm. So it is mainly focused on time sharing techniques. Whenever there is a need for sharing the time, in that time you will be using round robin algorithm. So it is very simple and easy to use and starvation free. Another one disadvantage of SJF algorithm is it has more starvation, because whenever a process having short execution time entering the CPU, that process will be allotted with the CPU. That results in long process execution time process to be in the waiting state for more amount of time. So SJF leads in starvation, whereas in round robin it will be starvation free. And it is the one of the most widely used algorithm, and it is preemptive. So let's discuss some problems regarding to this SJF and round robin algorithm. These questions were asked in previous gate question. So take a notebook and note it down. So this is the question. Consider the following set of processes assumed to have arrived at time 0. Consider the CPU scheduling algorithms, shortest job first and round robin. For round robin, assume that the processes are scheduled in the order P1, P2, P3, P4. If the time quantum for round robin is 4 milliseconds, then the absolute value of the difference between the average turnaround time of SJF and round robin. So this is the question you have to find, and you have to round off the answer to the 2 decimal values. So you have to find this. So initially you have to work for SJF algorithm, and then we can move on to round robin algorithm. After finding the turnaround time of these 2 algorithms, then we have to find the difference and you have to give the answer. Okay. So hope you all understand this question. Let's start with solving this question. So this is the table they have given. So whenever you are having a question like this, surely there will be a table given. In this you will have process, and below that burst time. What is burst time? It is the execution time, and ms represents milliseconds. So for process P1, the execution time is 8 milliseconds, and for process P2 it is 7, and for process P3 it is 2, and for process P4 it is 4. So these are the process they have given, and burst time also they have given. So what is burst time? It is the execution time. So these 2 things they have given in the problem. So and make sure whenever the question is about round robin, surely they will be giving time quantum. Without time quantum, you can't be solved that question. So let's start solving this question. So first, shortest job first scheduling algorithm. So whenever you are going to solve a problem, you have to draw a Gantt chart. So Gantt chart is used for representing how the process is executing and what is the execution time. So if you see this table, so there are 4 processes, and which process is having shortest execution time, so that will be allotted first. If you see here, the process P3 has the shortest execution time too. So the process P3 is allotted with the CPU. So that will be your first process. Then again you have to see the table. So which one is having second shortest execution time? As you see here, it is P4. So P4 is allotted with the CPU. So initially P3 starts at the time 0 and its execution time is 2. So that's why you are giving the number as 2 in this place in the Gantt chart. And next P4 is entering the CPU. So already 2 milliseconds is over for P3. So what is the execution time for P4? It's 4. So already 2 is completed, and P4 is having 4 execution time. So 4 plus 2, 6. So that's why you are using 6 here. So totally P3 is completed in 2 milliseconds and P4 is completed in 6 milliseconds. And next process what we are going to schedule is P2. So what is the execution time of P2? It is 7 milliseconds. So again P2 is allotted. Already 6 milliseconds is over, and P2 execution time is 7. So 6 plus 7, it is 13. And finally the process P1 is allotted, and the execution time of P1 is 8. So 13 plus 8, it's 21. So that's why you are representing the number here. So P3 is 2 and P4 is 6, P2 is 13. And P1 it's 21. So this is the representation of Gantt chart. So whenever you are solving a problem, you must draw this Gantt chart. On seeing this Gantt chart, you can easily solve the problem. So now the task is you have to find the average turnaround time. So average turnaround time. So what is the formula for average turnaround time? We can go to that slide and we can have a look on it. So turnaround time is the difference between completion time minus arrival time. So how far the process is completing, that is minus arrival time. So remember, completion time minus arrival time. So let's go to the problem. Here the completion time of process P1. So here we have given in the order of process P1, P2, P3, P4. and the process P1 completion time is 21 and there is no waiting time, so it is minus 0. And for process P2 the completion time is 13, so we are writing as 13 minus 0, there is no waiting time, that's why we are given as 0. And then the process P3 the execution time is 2 and the waiting time is 0. And finally the process P4 the execution time is 6 and the waiting time is 0. So we are doing this and you will be getting the turnaround time. But the question is average turnaround time. So you have to find the turnaround time and you have to divide by 4. Why we are using 4 here? We are having 4 process, so we are writing 4 here. So if you simplify this, you will be getting answer as 10.5 milliseconds. So this is what we have to do for SJF algorithm. Like the same way you have to do for round robin algorithm also. In the same way you have to represent the Gantt chart. In round robin algorithm the time quantum is given. So in this problem the time quantum is 4 milliseconds. So let's start with round robin algorithm. So in round robin algorithm initially we will be allotting the resources based on the order. So first the process P1 will enter and what is the time quantum? 4 milliseconds. So process P1 will be executed for only 4 milliseconds and process P1 will be moved to the waiting state. Next process P2 will be allotted. So in process P1 total execution time is 8 but it is allotted with only 4 milliseconds. So remaining 4 milliseconds is left. Then process P2 is entering and P2 execution time is 7 and as it is round robin algorithm the time quantum is 4. So remaining 3 seconds it will not be executed. Again the process P2 will be moved to the queue. And next process P3 will be entered. So process P3 execution time is 2. So overall the process P3 will be completing the process. And the last one the process P4. So the P4 execution time is also 4 which is within the time quantum. So process P4 will also be completed. So whether the process is done? No, it's not done. Again the P1 is having some remaining milliseconds because the P1 execution time is 8. But as the time quantum is 4, only 4 milliseconds was allotted. Remaining 4 milliseconds we are having. So again the process P1 is moved from the waiting state to the ready state. So again P1 will be entered and the remaining 4 milliseconds will be completed. And finally the process P2 will be allotted. Here the total execution time is 7. Already 4 is completed. So remaining is 3. Again the 3 milliseconds will be executed and the process P2 is done. So hope you all understand. So this is the Gantt chart for round robin algorithm. So same way we are going to find the turnaround time first and then we are going to find the average turnaround time. So what is the formula for turnaround time? The difference between the completion time minus waiting time. This is the formula for turnaround time. So let's take the process P1. So what is the completion time of process P1? It's 18. So initially it's completed 4 milliseconds. After that again it is allotted with CPU. So total completion time of process P1 is 18. So that's why we are writing 18 here. And is there any waiting time? There is no waiting time, so it is 0. And similarly for process P2 the total time taken is 21 and the waiting time is 0. And for P3 the total time taken is 10 and the waiting time is 0. And for P4 the total time taken is 14 and the waiting time is 0. And altogether you have to find the sum and as it is average we are dividing by 4. There are 4 processes, so we are dividing by 4 and the answer what you have got is 15.75. So for shortest job first we got the average turnaround time as 10.5 milliseconds and for round robin we got the time as 15.75. And the question is you have to find the difference between the average turnaround time of SJF and round robin. So if you find the difference the answer will be 5.25 milliseconds. So that is your final answer. So you can see the option and you can tick as option B correct answer. So this is your first question. This is the last question we are going to see in today's class. Let's see what is the question is. Consider an arbitrary set of CPU bound processes with unequal CPU burst length submitted at the same time to a computer system. Which one of the following process scheduling algorithm would minimize the average waiting time in the ready queue. So the question is, which scheduling algorithm, if we use, the waiting time will be minimum. Let's see the options given here. First one is shortest remaining time first. Second one is round robin with time quantum less than the shortest CPU burst. Third one is uniform random. And the last question is highest priority first with priority proportional to CPU burst length key. So comparing to all this algorithm, the best option is shortest remaining time first. Why? Because it is a preemptive SJF scheduling algorithm. Whenever a process is entering the CPU, it will be allotted with the resources. So the average waiting time is very less. So the option is A, shortest remaining time first algorithm. So, okay students, hope you all understood about today's class. If you have any doubts, you can comment in the below video. Thanks for watching.